Calculus is hard because it's vastly different from other mathematics. It introduces completely new concepts, and often when students are only taught the applications of these concepts, meaning how to solve problems, rather than what the concepts actually mean, calculus may appear unintuitive and frustrating to new students. A great example of this is the integral, which may seem daunting when looking at its formula and practical application, but in reality is a pretty straightforward concept. Today, I will attempt to illustrate this by explaining the idea of an integral using rudimentary examples and without any complex math. Let's say we are trying to find the area of an unknown shape. One way to do this is by taking something with an area we do know, for example, quarters, and filling the shape with them. This results in a decent estimate of the shape's area. However, this estimation is far from exact, as seen with the gaps between the quarters and the crossover of the quarters over the edges of the shape. One way to make this estimation better would be to use a smaller object, for example, these nickels. This results in a more accurate estimate, but we can see that the estimate is still not exact. As we continue to use smaller and smaller objects, our estimates will become more and more accurate. Still, any rational size, no matter how small, will always yield an imperfect estimate of the area. The only way to find the exact area of this shape would be to slice it into infinitely small parts and sum the area of these parts. Because each slice is infinitely tiny, there would be no gaps or any crossover over the edges of the shape, and all of the slices combined would therefore perfectly map the shape's area. In short, an integral does this, allowing us to take the precise area of 2D shapes.